Earth's shield is weakening. In the past 3,000 years, our planet's magnetic field has lost about 30% of its strength, and it's still dropping. But here's what most people don't know. This might be just the beginning of something much bigger. Stay with me, because I'm about to show you how this invisible force protects us every single day, and what might happen when it starts to fail. The magnetic shield. Earth's magnetic field is our planet's first line of defense, an invisible shield stretching far into space. Without it, Earth would look a lot more like Mars, a barren world, stripped of its atmosphere by the solar wind. But what exactly is this shield, and how does it work? Earth acts like a giant bar magnet, but instead of a solid piece of metal, the source is a massive ocean of liquid iron, swirling deep beneath our feet. This molten sea, about 1,800 miles below the surface, creates electrical currents hundreds of miles wide, flowing at thousands of miles per hour as Earth rotates. Scientists call this the geodynamo, nature's own power plant. The spinning metal creates a magnetic bubble around Earth called the magnetosphere. It's not a perfect sphere, it's more like a windsock in space. The solar wind, a stream of charged particles from the sun, compresses it on the day side and stretches it into a long tail on the night side. But here's the really cool part. This magnetic field creates two giant donut-shaped zones called the Van Allen belts, which trap harmful radiation from space. Think of them as Earth's very own particle accelerator, catching cosmic rays and solar particles before they can reach us. But this shield isn't as stable as we once thought. In fact, right now something strange is happening to our magnetic defenses, and it's happening faster than anyone expected. The magnetic flip. Remember when I said our magnetic shield is weakening? Well, scientists have discovered a massive weak spot over the South Atlantic Ocean, stretching from South America to Africa. They call it the South Atlantic Anomaly, and it's like a dent in our magnetic armor, where the field is significantly weaker than normal. This weak spot isn't just an interesting scientific curiosity, it's already causing problems. Satellites passing through this region regularly experience electronic glitches and failures. It's like they're passing through a cosmic weak spot where our shield can't protect them as well. But that's not all. Earth's magnetic poles are on the move. The magnetic North Pole is racing towards Siberia at an astounding 34 miles per year. That's about 3 times faster than it was moving in the 1990s. Imagine if your compass started becoming less reliable every year. Scientists have found evidence of this pattern before. By studying ancient rocks, they've discovered that Earth's magnetic field has flipped completely, with north becoming south and south becoming north, hundreds of times in our planet's history. The last major reversal happened about 780,000 years ago. But how does a magnetic flip actually work? Remember that ocean of liquid iron? Changes in how it flows can weaken some parts of the field and strengthen others. During a reversal, the field doesn't just switch off and on like a light switch. It's more like a dimmer that gradually fades down and then builds back up in the opposite direction. The process can take anywhere from a few hundred to a few thousand years to complete. During this time, we wouldn't be left completely defenseless. The field becomes more complex, with multiple magnetic poles popping up in unexpected places. Think of it like a choir transitioning between songs. There's a period where both melodies overlap. What's crucial to understand is that we're not necessarily headed for an imminent flip. Scientists have identified shorter events called excursions, where the field weakens significantly but then recovers without fully reversing. These happen about 10 times more frequently than full reversals, and we might be entering one of these periods now. Life on Earth. But what does all this mean for life on Earth? First, the good news. We're not heading for a doomsday scenario. Remember, life on Earth has survived hundreds of these reversals before. In fact, there's no evidence that past reversals caused any mass extinctions. The most immediate effects are already visible in our technology. Satellites passing through the South Atlantic anomaly need extra shielding, and some even shut down their sensitive electronics when passing through this region. As the field continues to weaken, these effects could become more widespread. What about radiation reaching Earth's surface? Here's something most people don't know. Our atmosphere is actually our main shield against radiation, and it's as effective as a 13-foot thick concrete wall. Even if the magnetic field weakens significantly, the atmosphere will still protect us from most harmful radiation. However, some animals might face challenges. Species that use magnetic fields for navigation, like sea turtles, whales, and some birds, would need to adapt. But given that these changes happen over many generations, they would likely have time to evolve new navigation strategies. Scientists estimate that at the current rate of decay, it might take several centuries, or even a millennium, before we reach a critical point. This gives us time to prepare our technology and infrastructure. Space agencies are already developing better radiation shielding for satellites and spacecraft. Power grid operators are installing equipment to protect against geomagnetic storms, which could become more common as the field weakens. We're living in a unique time where we can actually study this process as it happens. With satellites like the European Space Agency's Swarm mission constantly monitoring our magnetic field, we're learning more about these changes than ever before. Final thoughts. So while Earth's magnetic field is indeed changing, it's not time to panic. This is a slow, natural process that our planet has gone through many times before. What makes this time different is that we're here to witness it and understand it. If you found this look into Earth's magnetic future interesting, hit subscribe for more videos about our changing planet. Tell me in the comments what surprised you most, the fact that the field is weakening, or that our atmosphere is actually our main shield against radiation. Don't forget to watch the video on the right and stay curious. Thanks for being part of this journey into the unknown forces shaping our world. Earth's magnetic field isn't just shifting, it's unraveling in ways that could rewrite life as we know it. Right now, deep beneath our feet, a planetary-scale catastrophe is brewing, one that could leave humanity exposed to cosmic forces we've never had to face. The latest satellite data reveals something terrifying. The South Atlantic anomaly, that growing weak spot in our magnetic armor, is expanding faster than predicted, stretching wider every year like an open wound in Earth's protective shield. Imagine a world where auroras don't just dance at the poles, but explode across the entire sky. During past magnetic flips, scientists believe the northern and southern lights may have appeared near the equator, turning night into day with radioactive color. But this dazzling display comes at a horrific cost. Without our full magnetic shield, solar storms, like the Carrington event of 1859, which set telegraph stations on fire, could become apocalyptic. A single massive solar flare hitting during the flip's weakest phase, could fry global power grids, knock out satellites, and send civilization back to the 1800s overnight. And here's the nightmare no one's talking about. Radiation levels at high altitudes could become lethal. Commercial flights crossing the South Atlantic anomaly already report increased radiation exposure, but during a full reversal, transatlantic flights might require lead shielding just to keep passengers safe. Astronauts? They'd face a death sentence without extraordinary protection. The International Space Station might need to be abandoned entirely during the worst phases. But the real shocker lies in Earth's crust. Ancient lava flows tell a chilling story. Rocks frozen in time during past reversals show something horrifying. The magnetic field didn't just flip, it shattered into dozens of mini-poles. Picture a world where your compass spins wildly, where north could be in Africa one century and Antarctica the next. Navigation systems from ships to smartphones would fail catastrophically. Yet amidst this chaos, nature holds an even darker secret. Deep-sea sediment cores reveal that during the last flip, Earth's ozone layer may have temporarily collapsed. Without this second protective layer, UV radiation could have spiked to 300% of normal levels, enough to cause mass blindness in animals and trigger skin cancer epidemics. Some researchers now fear we may be seeing early warning signs. The recent unexplained thinning of the ozone layer over populated areas might not just be from chemicals, but from the magnetic field's accelerating collapse. The most terrifying part? We're flying blind. Modern humans have never witnessed a full reversal. The geological record shows some flips completed in as little as 200 years, a single human lifetime. If that happens now, with our fragile web of technology, the results could make climate change look like a minor inconvenience. Power grids would need complete redesign. Global positioning systems would become unreliable. Even migratory species could spiral into chaos, with whales beaching themselves as their internal compasses fail. Yet in this crisis lies an astonishing opportunity. For the first time in history, we have the technology to track these changes in real time. The European Space Agency's swarm satellites are mapping the magnetic field's death throes with unprecedented precision. Scientists are racing to develop predictive models, not just to understand the flip, but to harden our civilization against it. From self-correcting power grids to radiation-proof data centers, humanity might be forced to evolve its technology faster than ever before. This isn't science fiction. It's our children's future. The magnetic field's collapse won't wait for debates or denial. It's happening now, invisible and unstoppable, beneath our very feet. The question isn't whether we can stop it. We can't. The real question is, will we be ready when the compass finally spins out of control? The clock is ticking, and Earth isn't waiting for permission to flip. The ground beneath your feet is alive with electric currents you can't see, a swirling, molten orchestra conducting Earth's magnetic symphony. But right now, that symphony is descending into chaos, and the instruments are playing out of tune. Cutting-edge research from the University of Leeds reveals something startling. The liquid iron in Earth's outer core is developing turbulent eddies, unlike anything seen in computer simulations. These rogue currents aren't just weakening our magnetic shield, they're tearing it apart from the inside. Satellites are detecting bizarre magnetic pulses, sudden, unexplained spikes in field strength that appear and vanish like cosmic Morse code. Some scientists believe these could be early warning signs of what's called a geomagnetic jerk, a sudden shift in the field's behavior that can't be predicted. In 2017, the entire magnetic field lurched westward in a movement that left researchers stunned. Now, new data suggests these jerks might be happening more frequently, like a dying star's final flickers before going supernova. The consequences are already creeping into our daily lives in ways most people don't realize. Airports are quietly updating their runway numbers as magnetic north races towards Siberia at 55 kilometers per year. That's faster than a sprinting Olympic athlete. In Alaska and Canada, indigenous hunters report their traditional navigation knowledge becoming unreliable as the magnetic field warps above them. Even your smartphone's compass app is lying to you. More often, tech companies are scrambling to update algorithms to account for the accelerating drift. Beneath the Pacific Ocean, scientists have discovered a continent-sized blob of molten rock slowly rising toward the seafloor. This massive anomaly, dubbed the Pacific LLSVP, may be disrupting core flows in ways we don't yet understand. Some theorists suggest it could be acting like a giant thumb, pressing down on the geodynamo, distorting the magnetic field in unpredictable ways. If they're right, this silent upheaval from the deep might be the real puppet master behind the coming magnetic revolution. The most disturbing evidence comes from Antarctica. Ice cores drilled at the South Pole contain radioactive isotopes normally filtered out by Earth's magnetic field. But during past reversals, these dangerous particles spiked to alarming levels. What's chilling is that modern ice samples are starting to show similar patterns. It's as if our planet is slowly developing radiation leaks in its protective shell. And we're only now noticing the drips. Meanwhile, strange things are happening at the edge of space. NASA's ICON mission recently discovered that when the magnetic field weakens, solar winds can actually push Earth's atmosphere around like a cosmic tide. This atmospheric drag is already shortening satellite lifespans and could one day make low Earth orbit dangerously unpredictable for space stations and telescopes. Perhaps most unsettling is what scientists aren't seeing. Ancient tree rings from the last reversal show periods of stunted growth, hinting at possible climate disruptions we don't yet understand. Coral fossils suggest ocean currents went haywire during past flips. Even more worrying, our current climate crisis might interact with the magnetic collapse in ways no computer model can predict, a potential twin catastrophe of geomagnetic and climate chaos. Yet in this unfolding drama lies one of science's greatest opportunities. For the first time, we have sensors in space, on land, and in the oceans tracking this transformation in real time. The data pouring in could unlock secrets about Earth's core that have eluded us for centuries. Some researchers believe understanding the flip might finally answer fundamental questions, like why Earth has a magnetic field at all, when Mars lost theirs billions of years ago. This isn't just about compass needles going wild, it's about rewriting the rules of how our planet works. The magnetic field's collapse is peeling back layers of Earth's mysteries like an onion, revealing truths we're only beginning to comprehend. One thing is certain: the ground may feel solid beneath your feet, but the foundation of our world is more fragile and more fascinating than we ever imagined. The real question isn't what the magnetic flip will do to Earth, but what Earth will do to survive it. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos